Hi everyone. So in this video I'll be discussing about another problem on stacks, which is to reverse the elements of a stack. So let's say we have a stack with some elements inside it and we want to reverse the order of elements in the stack. So for example, we have a stack in which 4 is the topmost element, then we have 3, then 2, and then we have 1. And after reversing the stack, 1 will become the topmost element, then 2, then 3, then 4. So how do we approach this problem? So to reverse the elements of a stack, what we can do is we can one by one place each of the element at the correct order in the reversed stack. So let's say we have the 4 as the topmost element. So in the reversed order, we want 4 as the bottommost element. So first we will try to move 4 to the bottommost place. Then we have 3. So then we can try to move 3 to the second element from the bottom. And similarly, we can try to place each of the elements in the correct order in the reverse stack. So to do this operation, we can use some extra space to store all the other elements other than the element which we want to store at the correct place. So I'll demonstrate this through an animation. So this is the stack which we have initially. So we'll move 4 out of this stack and then we'll place all the other elements in the temporary stack. Now we'll move 4 to the bottommost place and then move all the other elements back into the original stack. So now 4 is placed in the correct order in the reversed stack. Now we want to place 3 at the correct order. So what we'll do is we'll move 3 out and then move the other elements to the temporary stack. Now we have moved 3 to the correct place. And now we'll move back the elements back into the original stack. So after 2 iterations, we have 4 and 3 at the correct place. Now we have 2 more elements remaining. So similarly, we'll move 2 out, move the remaining elements in the temporary stack, move back 2, and then move back the elements from the temporary stack into the original stack. So after 4 iterations, we see that the stack has been reversed. So if we want to summarize this algorithm, so what we have done is, first for each iteration, we pop out the topmost element, then we push the remaining n-1 elements to the other stack, and then push the top element back. Then again we pop out the top element, push the n-2 elements to the other stack, push the top element back, and then repeat the above process until the stack is reversed. So after n iterations, we'll see that the stack has been reversed. So what will be the time complexity of this algorithm? So since for placing each element at the correct position, we move the remaining elements to the other stack one by one. So to place the topmost element at the correct place, we need n operations for the first iteration. Similarly, to place the second top element to the correct place, we need n-1 operations. So in total, we'll need n plus n-1 plus n-2 until the last element, which if we can see carefully, is the sum of first n natural numbers, which is n into n plus 1 by 2 operations. Hence the total time complexity of this algorithm will be order of n square. So another way to solve this problem could be using recursion, which I'll be discussing in the next video. So for now, I'll try to code this particular approach in C++. So first I'll create a stack. Let's push some elements inside the stack. Now let's create a function to reverse the stack. For this we need one temporary stack, and is the total number of elements inside the stack. So total we'll need and operations. So we create a loop, then in each iteration what we'll do is first we will pop the topmost element, and then move the remaining elements remaining n minus I elements to the temporary stack. Now we'll push the topmost element, and now we'll push back all the elements from the temporary stack into the original stack. In this way the stack will be reversed. So let's also create one function to print the stack. And notice that here we are not passing the stack by reference, so whatever elements will be popping out, it won't affect the original stack, whereas in the sort stack function we are passing the stack by reference, so the original stack will be reversed in the reverse stack function. So let's first print the stack without reversing it. So this will be stack before reversing. Then let's reverse the stack. And then again print it after reversing. Let's compile this program. So before reversing the order was 1 2 3 4, and after reversing the order is 4 3 2 1. I'll share the link to this code in the description. Thank you.